The confusion matrix. Confusion.
Right, and we're rolling. Good morning, Alex. How are you?
I'm very well, thank you, Pete. The clouds have rolled in over Scotland. The temperature has dropped. I am no longer basting in my own juices, and therefore a certain amount happier for it.
Well, that's good for you. I am basting, but I don't mind a bit of basting occasionally.
We're British, right? We like to, crisp ourselves up in the blazing sun because we see it so infrequently. When the sun comes out, we have to go and roast ourselves. It's part of the culture.
It wouldn't be the same without that. So, basting aside, I think today we're going to talk about the sort of second half on our chat around testing and doing QA on large language models. Last time we talked about the supply side, so the sort of testing that you do in order to create good training data. So telling models what's good and what's bad, and that gets fed in and hopefully makes them better next time round. But now we want to talk about the demand side, which is more of traditional, if you like, where you've created some sort of application or workflow that includes an LLM, and how do you test that and make sure it's doing what you want? And there's got to be some pitfalls here. So, do you want to open with some initial thoughts on trying to test a model within an application or an agent or something like that?
Yeah. I can monologue on this for the next hour. I think one thing we need to make clear at the beginning of this is that I don't think we've got solutions. We're going to spend a lot of time talking about what the challenges are, and I think that's largely because the solutions don't really exist yet. So what are we talking about here? Well, I think we're going to get into the realms of drawing parallels with coding, right? Because it takes us into some really interesting and somewhat thorny territory. So the standard use case for a language model might be the ChatGPT app or a text box, whereby a human types in a query, give me the biography of Taylor Swift, and the model responds with some sort of text that has some long or short version of that. It's a fairly well understood timeline. One of the most famous humans who ever lived and currently lives, and all in pretty good shape. If you're a fan, you probably know it all. If you're not, you don't. But it may or may not be completely accurate. The most recent models are pretty decent with stuff like this. You can largely trust them, and so it's probably quite accurate. But if you then typed in, shut your client down again and typed in the same query, exactly the same words, you're going to get a different result, right? Now, it might still be roughly the same amount of words in roughly the same format with roughly the same information, but the words will be in a different order. It will be stated differently. You might have some bullets where you had some paragraphs before, so different formatting, blah, 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 and it may be more or less accurate. From a human end user perspective, it's much of a muchness, assuming your second iteration didn't go off the rails. And I don't think anyone particularly cares that the model presented the same data in different ways. And in fact, most people aren't going to type in the same query twice. It's more likely to, you forgot what it told you, and the next time you typed in a query, it was slightly different. So they're probably not even going to notice a lot of these inconsistencies. And that's all good, right? In end user world, a level of randomness is perfectly acceptable.
The difference as well from a person thinking about testing, like a software tester, is end user generally is seeing things once a day, or once every time they use a system. But as a tester, you're doing it repetitively. So it does mean that we as testers, if you like, see a lot of things coming up, especially large language models, that you won't see so much as a user, because we'll sit there with a query, we'll hit enter, see what it says, we'll backtrack, hit enter, do it 5 times and record all 5 examples, do a compare and say, look how different they are. But no one in their right mind's doing that in the real world. So it might seem as testers that we can get a little bit pedantic almost. Of course, if you go back to the software world, once you get that right answer, then that's it. And you automate that test, because once it comes out with the answer of, I asked it this and it produced this, then that's it. And you can now set up an assertion for that. When I put in A, it gives me B. Always test for B. You hard code that in. You say, when I give it A, it will give you this answer. And if that fails, that's then a test failure. And so, you don't repeat the test as such once you've got it right. But of course, with LLMs, you couldn't do that level of, oh, well, I give it A, it's going to be exactly B, like you say, because the language changes slightly, the format changes slightly. So it's going to fail every time.
Right.
But I just wanted to throw that in, that as testers we see things which people don't, just by the nature of that's what we're testing for. But it does create a sort of a weirdness between how we might talk about it and how normal people see it.
Well, exactly. And so we're back to this where we sort of started off yesterday in probabilistic versus deterministic territory. And so the models are probabilistic or stochastic, or whatever word you want to use, which is exemplified by the example that I just gave, right? And from as I said, from an end user perspective, it's largely neither here nor there. But from a technical or coding or testing perspective, if I wrote a little function in whatever programming language, and every time I ran that function, it gave me a different result, assuming that's not what I wanted. Obviously, you can write functions with random elements to them, but if my function was to add 2 numbers, and I put in 4 plus 4 and it gave me 8, and then the next time it gave me 9, and then the next time it gave me 5, then that's problematic, right? So that system has somehow become non-deterministic. And so we get into this realm now where we have this sort of division between code and sort of output, right? And so over one side, you've got models, which are themselves not code. They're mathematical entities. They might have code wrappers, but ultimately the model itself is just a bunch of numbers, right? And and the deployment of that is by its nature non-deterministic. And where you can keep your code and you can keep your models separate, you're right? And that's what you see when you've got ChatGPT's app. You've got a deterministic app that knows to send your prompt to the API, get a response back, present a response, right? It doesn't really care what the response was, right? It doesn't care what the prompt was. It's not really cognizant of any of it. The two domains are kept almost clinically separate, right? Which is the way that we're used to doing things. So right now we're in that state. We're in pretty good space, right? Nothing's being violated. The two worlds are separate. The user's happy. The programmer's happy. But what happens if, as is increasingly the case, those two worlds merge? And for example, if as an end user, I'm a data scientist, analyst, something like that, and I'm crafting prompts that will return code that will allow me to, filter a data frame or do some aggregate on a data frame or whatever, some SQL to query a database, whatever you got, right? Now, the thing that's returned, let's just keep it simple and say that it's a chunk of SQL. There's probably a couple of different ways of doing that. There's probably a couple of different right ways to do it. And there's an almost infinite number of wrong ways to do it. And you're going to get one of those, right? But you're not quite sure which one. And that immediately poses a problem because, again, as an end user with that query, I can sort of field the randomness. I can deal with it. But if then that isn't quite the case, actually, you've got this encapsulated in an end-to-end, automated function. There's no end user in there to sort of field the fact that it's gone slightly awry, or the query that's sent back either doesn't work or is producing incorrect results. And immediately we hit a software problem. Because as you pointed out earlier, when you're testing software, you create functions, or even as a human testing software, you have expectations of outputs. But you've written, as a developer, you've written tests that say, well, if I put 4 and 4 into this function, it should give me 8. And if it doesn't give me 8, then the function's broken. But if you have a stochastic element in there, as part of the way that the machine itself, the code operates, then you've got a much bigger problem because you've got to handle for an almost infinite amount of edge cases. And so that's sort of the first layer, right? The first layer of issue that we have here. And it's one that I think I spend a lot of time wrestling with, in my vibe coding odyssey. And I think it's going to continue to be a headache for coders for a long time to come. And I think actually it's the part of this conversation that relates most pertinently back to the last conversation we had, in that part of the reason the testing is being done, the quality assurance is being done supply side, is so that me as the consumer on the demand side is more likely to get consistent results, i.e., if I ask for a SQL query that does an aggregate, blah, 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 it should look like this because of thing A, B, C. You've told your reasoning model that's why I get the results that I get. And that it should mean that I much more consistently get the right result back in that particular scenario. But it's not guaranteed.
Yeah, absolutely. And interestingly, as you look more down the reasoning models, they're building in this self-testing QA into the reasoning process because it's just something that we do as humans. I mean, it's separated out in the software development world as it is in other engineering disciplines. And so it makes it a very specific stage and it's a very obvious thing to do. But it's something that we do as humans anyway. You think of something, something pops into your head. Our own brains are running some sort of QA over things which come in all the time. And I think the reasoning models start to lean in that direction. Okay, I'm doing this function. Okay, what am I expected to get from that? Well, it's probably this. Well, is there any way I can test that? Well, look, you can run this test. Oh, I ran that test and it didn't produce what I expected. Okay, maybe I need to rewrite that. And if you look at the reasoning models when they lay out their reasoning, that's some of the things which are going on.
Yeah, so what we're saying here is that these models are inherently stochastic. You are on the supply side, and you are trying to make life better for me by reducing the stochasticity of certain actions that are common and need to be as deterministic as possible without, constraining the model's ability to be creative or to use its inference to transfer methods for doing things from one scenario to another, right? So it needs that level of probabilistic freedom to say, well, if I can do a SQL, a group by on this table here with a text column and a numerical column, well, I can do exactly the same thing on this completely unrelated table in a different database, right? So you need a level of flexibility in there. You can't constrain it, and if you do constrain it, well, we're no better off than in the purely deterministic world, which has its charms, but you end up having to code for hundreds of cases to allow for some level of flexibility in your application. And so the issue is already we want our software, my endpoint software, to alter its behavior based on some facet of the user input dynamically, right? And so coding for that's a nightmare. But if you can throw a language model in the mix and use it to infer, anywhere someone's writing something in natural language. So, into the vibe coding world, write me a function or write me a small app that can read a CSV and just simply do a roll up on a couple of columns and just give me the result, right? And I want to just run that as a simple Python script. And so it's going to be able to do that without much problem. It's probably going to, use pandas under the hood or polars or something. And it's probably only like 10 lines of code or something. And we're sort of all right. We're in a pretty good state because now you've got, you put a language interface on the front of that where you say, here's what I want. It then translates that into some code and then it creates that code. But the same thing emerges here is that every time I run that, just like the Taylor Swift bio was going to be slightly different, and so the code will be slightly different. Now, if that code that you've written is integral to your application, it matters how different it is. So, for example, input parameters, the output of the function itself and the format of that and so on. And so you get to this world where you start to have to describe things really explicitly, right? So it needs to do this. It needs to take these inputs. Input 1 is going to be a string. Input 2 will be another string. There's a Boolean for this, output to JSON or output to Markdown, blah, blah, blah. And suddenly you've got effectively, if you break it down into bullet points, as a programmer, you look at that and you've said, well, okay, so I needed to write this function and I've basically written pseudocode, right? And actually I could have probably written the code itself almost as quickly, right? And so we have this weird world where applications start to plug in elements of language models which are non-deterministic and are based on things like natural language and the general whims of the user, that then output things which are non-deterministic and are based on, to use an anthropomorphizing term, the whims of the model. And there's almost an infinite degree of potential variance there. And how do you control for that so the end user is happy, you don't create bugs in the machine, and that you can ensure the quality of results? And this is talking very much in terms of measurable outputs, when you've got something within a system that has to just work, right? So there are multiple different endpoints that this application can get to. And so firstly, how do you test that all those endpoints are valid, right? But secondarily, how do you test that they're valid? But what if those endpoints are a Taylor Swift bio? How do you then test that Taylor Swift bio was accurate, right? Yeah. And so we've got all these potential outcomes. You've got code being generated internally that needs to work. It then needs to do what it's supposed to do. You end up with prompts in the system which are essentially pseudocode, right? But they need to be kept as prompts because you want that stochastic or non-deterministic element in there. And you've got to control for all of this. And from a software dev perspective, I thought in my naivety that these models were supposed to make things easier, right? But I mean, actually, you've just traded one problem for another.
Yeah, it does feel like that. I mean, I think some of the positive things is that someone that doesn't know how to code might still be able to write a decent prompt because they've been perhaps trained that way, breaking things down, being concise, writing out specs for work, tenders, anything like that is going to give you a predisposition for writing some quite good specifications, but you might not be a programmer. So it's opened the world up for you to be able to start to create some programming style operations and workflows without actually programming. So there's a big advantage there. And I think that's really one of the key selling points, right? Of large language models in general. But I totally agree. I mean, that in itself introduces a whole bunch of things, which is, well, coming from software backgrounds and engineering backgrounds, you know that you put a spec out there, you got to check what you get back. Whereas if you're just specking stuff out, you might not do that so rigorously. In other words, you're not looking to test it because that's not in your discipline. You just realize you can write some words down, do a quick one pager, as I like to think of these things, and wow, this thing's now rolling away and doing it for me. But I think using code as an example against something that's not code is a really good way to highlight the problem. So if you asked it to produce some code, like you say, it writes that code, it's getting some columns, it's doing some aggregation for you, it provides you that code back. You then run that code, literally, you press execute code and it fails. So you immediately know that there's something wrong. If you are instead asking for the description or some elements of a product from product information from a big database of the products that we sell as a company, and you're a customer and you say, oh yeah, I've got this TV, does it do this, does it do that? If you're asking for, does this tablet have a 1080 screen definition, something like that, you're going, oh well, I'm looking for a 1080p definition tablet. Is this one 1080p? Yes, it is. Oh, great. Well, I'll go and buy that one. And if that information is wrong, you don't know it's wrong. You're now taking actions based on incorrect facts, and that's quite a factual one, but you could see how something that's a little bit more woolly could really, it can lead you down the garden path here.
Yeah. And I think that, so we got quality assurance in terms of, is my application working as expected now that I put this big bloody random machine in the middle of it? And then you've got, so is the machine functioning? And then you've got, are we providing the right information about our products or services, or, to the end user? If your website is a shop and item X is £10, you can always, test that. You can put in tests that make sure that value matches the value in the database, right? The canonical value. Mm-hmm. But the moment you then put a chat box on it that says, well, give me some more information about this, you're going to struggle to guarantee that it gives the right results and consistently, right? So in testing, we test this endpoint. We ask it a question in the same way every time. Can you give me more details about this screen? And it tells you it's 1080p and is, £200, when actually it is 1080p, but it's actually £500, right? And you can test to make sure it gives you the right results, and perhaps in testing it's consistently correct, but you can't account for every scenario. Automatically you're thinking, well, hold on, I can't just test this with the same string every time, right? Because different configurations of input will give different outputs. So now what do? Okay, I can mock up hundreds perhaps of different phrases to ask the same thing, right? And then test the results. And then say, okay, we're getting consistent results there as well, in my test suite. And now I unleash it on the users. Of course, it's not hundreds. It's infinite different ways of asking things, and potentially in a chat stream where actually the question about price or the question about the definition of the screen is like the 7th exchange down. And so now you've got no control at all over the context. They might have gone on in to have a random chat with the machine about a different product, and the model itself is going to be working at cross purposes. And if it gets things wrong at that point, you're not going to blame it, right? You think, well, actually, you've confused the buggery out of it. But from an end user's perspective, right? No, I just asked you the price, right? And you told me the wrong one. And it's like, you can't go to them. Yeah, but mate, you confused the hell out of it. Can you be nicer to our model, right? And help, right? They're going to go piss off, right? And rightly. And so you can't control for that. You can't test for it. And this is in a world where there is a right and a wrong answer, right? No, it's £200. That's how much it costs, right? It got it wrong, right? Things get even more hairy when you get into the realms where the answer is subjective, right? And so how do you test for this? How do you make sure that through all the levels of delivery that you're getting consistent results? And we can, when you write a piece of deterministic software, these are quite complicated. There's, classes upon classes, algorithms upon algorithms. There are leaks. There is no such thing as bug-free software. You can hit an edge case, and this supposedly deterministic thing will give something that looks random, right? But then you can go through the code and figure out, actually, if you happen to do this, then that, and this, and then that, you trigger off this really odd edge case where it gets passed over here, and it gives you a wrong answer, right? Queries from the wrong database or something, right? So in a deterministic world, there's going to be some small amount of end user errors and things that, especially if you've got millions of users, someone will turn that up, right? And you can call that percentage 99.99%, correct, accurate, and functional for that many users that much of the time. But we're getting into a realm now where you've got so little control once you've put a model in the mix that you can't have 90. You probably can't have 90% of the time, right? Maybe you can, but whatever your tolerances are, if it's a shop and it's telling you the wrong price, well, you're going to put it in the basket and it's going to say the right price, right? Because the moment you're in the shopping basket, I assume you're in deterministic world. But if it's a bank, right, and you're having a chat with your bank and it's giving you wrong things, right? In the shop scenario, you're like, oh, that's bullshit. So how many times you've been to a physical shop, picked up something that says, that's a tenner, and you get to the till and it's the wrong price, right? I don't want to pay that much for it. It happens, right? But it doesn't happen with banks, right? That's not a thing. People will freak out if you get their data wrong, right? In a banking scenario. And so there are areas where I just don't see any way of plugging in, as it stands, a model and being able to use that, because you can't guarantee the outputs. And I mean, do you really have to test for everything, right? And so you can say your bank balance is, £1,000, and you go, well, it said the bank balance is £1,000. You intercept the model's response before it gets to the end user. you check that value against the database, right? And say, well, I can guarantee that it says the right thing, but can you, right? Because you've got to recognize when the model says something definitive, you've got to understand what the thing it said was. Then you've got to go and find the source for that data. Then you've got to check it, right? And so you've now got another string of things that can go wrong, right? And also you've had to build in a bunch of error checking all the way through the process. It's going to slow things down. It's going to cost you money. It's going to need extra systems that need support that can also go wrong. And you get to the world where you're like, well, why have we got that there, right? It's more trouble than it's worth to implement a chat box on my banking software.
Yeah, that's a very good case for making sure that you use, generative AI in a very judicial way. Do not plaster it across your business because it's not relevant in many cases. And I think this is really important. I could see a case, especially banking, with lots of people phoning up, where they're saying, because of the volume, we're getting 10,000 calls a day asking about this. If we can use a chat bot to take out 30% of those calls because it's good enough to answer a general query, and we see it as most of the time being good. And if it's not good, then the customer will stay on the line, perhaps slightly more irate than they would have been. But if you're eliminating 30% of 10,000 calls a day, then that's going to be worth doing. So I could see cases where you want to use it, but it needs to be in those general, more woolly cases where people aren't asking for specific details of things. They want pointers, they want general understanding. And if you have tested your model, with the documentation you've got, and the testing there is going to be, you are going to be looking at percentages. I've got 400 questions taken from customers over the last month, feed them in, and you're initially going to be getting humans checking those, saying, are they coming up with reasonable answers? Whether the response is reasonable. And that is going to form a bit of a test set. So if you have an upgrade in your model, like the recent upgrade of GPT-5, you've got 10,000 questions that you've been getting over the last couple of months. You've got reasonable answers, and you can use an older model that works quite well. So even if the new model brings out different answers, you can still use the old model to say, well, look, is it producing answers which are in the ballpark of this? I mean, even that in itself is not 100% deterministic, but I could see how you could do that and work out whether you're still, you've got a test suite there, and work out whether you're still, broadly speaking, answering the queries how you would like them to be answered.
I think, look, you bring up the call center example, and my chat box on a bank through a banking app, right, on your phone. Yeah. It's not a question as to whether that's desirable or appropriate. I want that chat box, right? I just need it to be 100% accurate. And I want, my call center to be, to replace 1/3 of the staff with bots. And in fact, the user experience might be better because of it. But the reality is you can't, right? It's not, I think part of the problem that's arisen here is that, yes, it's absolutely possible to implement a chat box through your banking app, right? It's not even hard, right? But if you need it to be 100% accurate, I would argue that is just not possible, and it never, ever will be with the large language model paradigm, right? And so you can build, and really the approach to this, and I think GPT-5 is actually an example of this, whereby you get models marking models homework, right? Which is a perfectly valid and in many cases robust approach, right? So the approach I take to vibe coding out apps is to have a model responsibility with the responsibility for coding, and another one with responsibility of marking that model's homework. It can actually be the same underlying model with a different prompt, or you can use, build it with GPT, test it with, or validate it with Claude or something, right? And actually, for my particular needs, given I don't need 100% accuracy, robustness, blah, 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 I'm quite tolerant of things going a bit wrong. It's perfectly valid to have models upon models upon models, right? And in fact, firstly, that's, traditional machine learning. That's exactly what ensemble approaches are, right? Nothing wrong here. Nothing's been violated. And as long as your expectations are set correctly, we're in a really, really happy place, right? But at the moment you start to put in provisos that say, no, I need reliability and accuracy, there is no number of models that you can throw at that's going to solve the problem. You might be able to mitigate it to a degree, but there's going to be a point to which throwing more models at the problem is going to be counterproductive. It's like the Mythical Man month, or the increasing the amount of code in a code base almost never improves that code base, right? In fact, usually degrades it. And it's no different here. And this is where we get back into this realms of the comparison of handling models within an environment that needs to be meaningfully deterministic, and clashing head on with the need to be able to manage that environment. And so a simple example here is that necessarily you've got a prompt within your technology stack that does something that you can handle for very, very robustly in a non-deterministic fashion within your application, within its testing, right? But still you've got a blob of human language text in there, right? And I don't think people tend to think about prompts, even system prompts particularly, as code. But in the scenario where, particularly from a case of a system prompt, your application's output will change and in theory break if your system prompt stops behaving consistently. And so an example for this is the stochastic element is getting the Taylor Swift bio. The application doesn't care really whether the bio is consistent or accurate, but what you need is for it to be returned in JSON in a certain form, or YAML, or Markdown formatted in a certain way, right? So you don't care about the text itself, but your application will break if the JSON is malformed, or it is has the wrong fields in it, or some of the fields are misnamed, which is something that's going to happen. And so you're all fine because you've got a tester, like a Pydantic model on the receiving end that will vomit and throw it back if it's not in the right format, right? So actually you think we've solved the problem, right? If it's not in the right format, I'll just keep asking until I get the right one, right? And so you think, oh, right, we're good. We've solved language models, until someone goes in there and changes one word in that prompt, right? Because it's not so rigorously managed. You can't put it through MyPy or something. You can't, go through and test the robustness of it because you can't see the output, right? You can test a Python function or a Java function just by running it, right? Now, we're in a world here now where someone's gone in and changed one word, and now it's not bringing back JSON ever in the right form, right? And so you have to then manage that system prompt as if it were code. And the word that they changed was and to but or something, or just deleted it accidentally, and that will break any normal piece of code to the point where you won't be able to check it in, right? But will you be able to check in this system prompt? Has it got the same level of rigorous testing? Is it as ring fenced as any other piece of code and say, don't touch this unless you absolutely need to, and then rigorously test the output, right? Because you change one word in a one character in a piece of Python code and it will probably break. If you change one character in a system prompt, you might still get the same thing, but you could get something radically different, right? And then what happens if the underlying model changes, right? Or you need to migrate to a different model? You're in a whole different realm because your system prompt will behave totally differently on Claude as it will on GPT, right? And so we're not only in the point where the prompts that you give to models start to look like code. No, they are code, right? But you can't then just sort of change that to code because that's not the point, right? Because they are not non-deterministic. The system prompt has to be the way that it has to be. And so you've got now a big block of what's ultimately qualitative human-derived text that needs to be managed like code. And I don't think a lot of people who aren't knee-deep in this stuff have even thought about that, right?
Yeah, I think that's absolutely a key point is, I mean, obviously we're from that background, we would apply our disciplines to it. But as you say, you've got system prompts, which has to be version controlled, same as code. You're using a model of which you need to version, and that needs to be change controlled, i.e. someone doesn't just use a different model on a Friday afternoon when everyone's gone home for the weekend. I mean, it was my early days in software development, which did happen. You're running a business and someone puts a change in on a Friday afternoon, and then before you know it, you've got a rule that says we do not do changes after Wednesday afternoon because we don't want to be coping with a software problem on a Saturday when no one's here, and they're quite natural things for us to lean into. And like you say, if you're just from the world of business and writing prompts, when you're going to start to think about, I've now got 8 different versions of that prompt, and when I change it, I'm going to, cause a problem. It's fine if it's just running one thing, but in a similar way to the spread of Excel over the years for workflows, you're going to have workflows that starts off with 1 or 2 prompts, which then lead into somebody else's 1 or 2 prompts, which then leads into somebody else's, and anyone in that chain can change something. And if it's not version controlled and change controlled and managed properly, the next thing you know, everything's wrong and nobody knows. Everyone's pointing their finger at everyone else. And we all know in a business context, when somebody says, whose fault is this? People are generally more defensive than they are forthcoming. So everyone's immediately going to say, no, I haven't done anything. Because that's just the natural human response.
Well, also people don't see changing written words, human language text as the same thing. If I said the cat sat on the mat, or I said the cat was sitting on the mat, right? There's nuance here. Linguistically, they are not the same, but the meaning is fine, right? And there's much more subtle stuff than that, where you can just change the word order and absolutely nothing changes, right? And so there are 20 different ways to say certain things, right? And they all mean, in the context that you state them, exactly the same thing, right? Which is not necessarily the same in code, right? And also you have to be a bit more measured about how you change things. And also people will put up with, we all know the thing where you can, delete random words from sentences, change word orders, change letter orders. And so it's now malformed English, but a human can look at it and know exactly what it says and means. You don't, if you remove the word and from a sentence, a human can usually figure out what you meant, and how many emails have you seen, or bloody hell, on Twitter or whatever on social media with people using all these strange patois. You can still read them. You know what I mean? And the same is just not true for code. And worse, when you put language models in the mix, they're some sort of hybrid between the way that humans can sort of flexibly interpret stuff, but also the way that machines need a certain level of order and lack some of the context that the human might for interpreting something. And, we're getting into some pretty shady territory quite quickly. And I think this delta is what's causing so many people problems, and to turn away from models in their entirety, and attributing that to the model, right? Saying, well, no, language models are not up to the job. When I'm saying, well, no, it's not. You're just wielding it wrong, and you're expecting the wrong things of it. And I mean, it's like expecting to be able to write a PowerPoint presentation in Excel. It's like, no, no, that's not how. That's not what it's for.
And I think that expectation, I think, is really key, because you can take this back to software. You can test software and you can come up with it and finish it and say, well, it does exactly what it says on the tin. But the key question is well, what it says on the tin, is that actually what the business needed? And in the early days of software, and probably I'm sure still a bit now, the answer was often, oh no, we got that wrong. We said we wanted it to do this. And it turns out that that's really nice, but it's not what we need to do to increase sales. And so, one of the early things about defining software is, don't ask users what they want. You ask them what they need. What do you need to improve things, not what do you want? Again, a subtlety in language. And I think it's the same here. I think, we talk about that example of, a call center, and, if you could reduce 3,000 hours of calls a day, that's got to be beneficial. But you've got to weigh that up with the problems it might cause if you're giving out wrong information to certain types of query. And if the downside of that is more irate customers that you then end up losing, you've got to outweigh, well, is it worth keeping on, the full 10,000 hours being coped with by humans? Because if we cut out the 3,000 hours, we make a saving, but we also lose more customers, and it's an ROI, return on investment type weighing up a decision. And that's always really should have been there for software, wasn't always there. And I think it's the same here. I think if you can see the benefits, even if this thing isn't 100% right, and I saw something today, people talking about it only being right, 40 to 70% in terms of, correctness. I'm sure it's a rough indicator, but it seems about right. But if you can create a case that says, even if it's only right 40% of the time, the savings we get from this and the negative impacts are minimal, then go ahead, and then tailor your, testing accordingly to that use case. But don't just, think it's a panacea. And as you say, if your expectation is, well, look, we can test the hell out of it, so we know it's only ever giving the right answer. Well, that is not the right answer, because that's not going to be possible with the current ways that the models work.
Yeah. And it's a minefield, and we're not even into the most thorny part, right? Which is sort of detecting strongly qualitative outputs for veracity or rigor or accuracy or anything, or things like plagiarism and stuff like that, right? And where there is a high degree of interpretation, right? How do you know when you got it to write a short story, when you got GPT to write a short story for you in the romance genre, that it hasn't almost word for word just nicked someone else's, right? And unless you've read all romance short stories, and maybe there are people out there that have, and even if you had, are you going to remember? You know what I mean? It's the whole thing where you get these plagiarism court cases between humans where, they're like, I've never heard this song, so how can I have copied it? Well, maybe that is true, but maybe they just heard it in over the speakers while they were doing some shopping, right, in a shopping centre, and they didn't even notice it, but they subconsciously taken in that melody, right? I think Chris Martin and the whole Coldplay Joe Satriani court case was along these lines, and it's like you simply can't know that is or isn't being plagiarized, and the same thing becomes with accuracy as answer. I'm not a Taylor Swift fan, so I don't know if that Taylor Swift bio was accurate or not. And even if then you have sort of QA bots out there whose job it is to verify things, or even QA humans like you get on Wikipedia. There's whole pages of like flame wars behind Wikipedia where people are arguing about what reality and truth is, right? That ultimately has to be moderated by someone with a veto who can just sort of say, well, no, we're going to settle with this as facts right now. And so we've got this whole sheen on the top of all of it that is simply trying to do things that humans are quite good at, i.e. picking up on nuances in language that change the meaning of a piece of text, in terms of sort of recognizing potential plagiarism, spotting patterns that are quite implicit. Like, how do you account for it? How do you even account for it in a controlled system, where you've only got a certain number of outputs? As the moment those outputs are subjective, how do you ensure that they meet certain quality criteria when the outputs can be infinite, and that a simple change in phrasing can totally change the meaning of a sentence or a paragraph, right? How do you ensure quality when the potential outputs are infinite? And I think that's a problem a lot of institutions going to have, and rightly so, because in the language model world, that's intractable, right? That is I would argue, an impossible problem to solve. And I remember having I don't know who it was, but I had a Blue Sky exchange ages ago with an academic who specializes in detecting plagiarism. And she was like, no, it's not possible to reliably detect plagiarism. Full stop. She was like, I was like, do you mean it's so hard it might as well be impossible? And she goes, no, it's just not possible. It's not a thing. It's not a thing that can ever happen, right? Now, that was just one person, whatever. But there is a view out there that this problem with education systems, which we haven't even touched upon, where plagiarism is a big issue, which is ultimately a problem that relates to quality, right? Just from the other direction. That they simply can't verify whether something is plagiarism or not. And if you happen to be in the sort of Coldplay Satriani problem, where you genuinely wrote this yourself, but having ambiently taken something else in, you could be ejected from university. You could get all sorts of punitive measures taken against you for potentially having plagiarized or cheated, which is a blight that could be on your record for a long time, when ultimately the system that was judging the plagiarism, made a coin toss and you fell on the wrong side of it, right?
Yeah, exactly. And classic machine.
Yeah, well, exactly, right? So the way that machine learning classifiers work, it's not a case of, you can set thresholds, but the decision between cat or dog when you feed that image in, if the boundary is, the split is somewhere between 50-50, I simply don't know, and I don't even have an inkling whether this is a cat or a dog. If it happens to be 50.00001% in favour of dog, it's going to choose dog, right? And you're going to assume that that's a good result, and it's actually it was a coin toss, right? And that sort of shit is just as pertinent in the language model world, and so these are not solid. This is not solid ground to build sort of principles and systems and laws or rules on top of. And geez, I feel like this whole conversation, 1 minute I'm going, defending language models, and the next I'm saying, well, this is a nightmare, run away, burn it with fire, all that stuff.
Well, that's and holding those two things at the same time is very, very tricky. And I think will lead us on to a conversation which we'll have for another day, which is with these things in mind, you can't 100% test it. And so what applications can you use it for where you don't have to worry about things being 100% right? And whilst that sounds like I can't think of anything like that, actually, there's quite a lot. And I think we'll have a session where we talk through good use cases for these. And actually where we think it's going, which is, down the personalization route, because I think where this all leads is you can't have a system which is good for everybody, but you might be able to have a system which is very good for one person. And so, I think that's a conversation for another day.
It really is, right?
But
and so we had a little short
Yeah.
list of conversations that were going to be the next episodes, and that was literally the next one, depending on how you view it, which was back into the world of vibe coding and writing software with an audience of one, and or writing or creating anything with an audience of one, and how that indeed short circuits some of these potential problems.
Exactly.
But it's only one aspect of that particular thing. So I think we have a really, really good lively conversation coming up about the software of an audience of one and what that means for the whole software space, which is really interesting to me at the moment.
Definitely. Well, very good. We certainly didn't solve anything there.
Good.
Brilliant.
Well, 2 hours on model testing and QA. I'm kind of done with that now.
Yeah, let's move on. Well, thank you very much.
Yes.
And we'll speak in soon. So thanks for listening.
Yeah. Cheers, everybody. Bye.
The confusion matrix. Confusion.